Power up. Welcome to Energypreneurs, where I bring to you the exciting new opportunities in solar power, battery, and electric cars. I'm your host, Sohail Hasni. I have been tracking and analyzing these technologies on LinkedIn and Twitter for more than 10 years. Now we meet on podcast.
Anyway, thank you again. Basically, you are one of the top battery expert that I know among many that I have spoken, but I think you have a very good understanding. So I think through this podcast, what we like to explore, what are the things that is happening and what are the trends you see coming, especially in batteries, because you talk about electric cars, you talk about the whole revolution that's happening in the energy sector is all driven by storage. Right?
Mm-hmm. Yes, it's
so maybe you can introduce yourself first and we try to understand the world from your perspective.
Okay, so thank you for having me in the podcast. And my name is Jukka Jarvinen, and I'm working as a battery, lithium-ion battery technology serial entrepreneur, and using my own personal brand, Akku Jukka, which is basically Akku is in Finnish battery, and my name is backwards battery, so that is a palindrome, Akku Jukka. I don't know, it was kind of maybe fate or something, but I fell in love with electric cars in 1992 when I drove my first electric car and adjusted my studies in the technical schools according to the battery technology and electric vehicles and transportation logistics. Then I've started several battery companies to do research and battery manufacturing, also deployment of energy storage systems and different kind of electric vehicles. And during the past about 20 years, several startups have, of course, started a bit too early. So that's why I need to be a serial and parallel entrepreneur. I learned that I need to have parallel projects in order to survive, basically. It became kind of a chaotic approach, but it has grown a lot of tentacles all over the world in different kind of projects. And I was able to collect a lot of data about different kind of battery projects and use that for my own R&D. Now we are globally in a situation that battery manufacturing is scaling up, and we are doing huge, big scaling project, which includes the raw material sources, cell manufacturing, packaging, system assembly, deliveries, and even the financing and batteries as in a service business models. So this is now the golden age or the lithium age of mankind, I would say. And we are now in the start of something big and wonderful, which is going to really knock the whole climate crisis out of the park. We'll be able to tackle so many problems with the batteries, and I'm very excited about it. So that's briefly what I'm doing, trying to push lithium battery business forward with new ways and new technologies.
I like that you're saying. So this is the lithium age. So coming ahead of us. Fantastic. Now, Jukka, will it be possible to, maybe some of our listeners have not much appreciation of the whole lithium value chain. So maybe you can explain how the lithium value chain works?
Well, if we take the lithium itself, raw material, then of course that's just one part of the business, because lithium is of course used in other industries too. But in lithium-ion batteries, it is not the most crucial component still. The biggest cost is usually either, depending on the cell design, it's either in a cathode or anode, or in the electrolytes. And if we look into the value chain, how it comes from the raw materials, mined raw ores to precursors and raw materials, and then cells, and goes all the way up to the financing. The most value is made in the financing at the moment. Mm-hmm. So that is the most. It's basically quite simple. You have certain percentage of capital gains on each step, but every time you refine the product to a bit more higher level of refining and more end product, like more is also the slice of that few percentage of the profit margin. So from the value chain, I've been trying to figure out this from kind of top down, thinking of the financing, how the energy trading is done currently with the fossil fuel industry, and how does it change in 15 years. So when we come down from the financing side and look into the operation and maintenance, for example, for energy storage assets, they are quite competitive and region-specific things. So it all boils down to the revenue stacks on the battery. That who are paying for the battery? Is it used only for, let's say, propulsing a three-wheeler taxi in the city streets, or does it use also demand response and provide energy storage overnight or something like that? So when you come from the operation and maintenance, you have there next, when coming down the kind of the engineering and building the assets into the place what it is. If it's a taxi fleet for batteries, leased batteries, or if it's a stationary energy storage. So someone has to actually put those assets in the place where they make the money. And when you come down to the next level, you have the system assembly and design. So someone has to make the battery system, put all the components together and get certificates and make take the approvals of specific regions. So if you go to USA or Asia or Europe, you have different kind of criteria for the system, including fire suppression and protection and insulations and everything like that. So you need to have certain specific knowledge on that too, on the regionally level. Then, of course, you have the modules, and it used to be the way that we get modules, or someone gets modules from a cell system assembly manufacturer. Someone provides the rack unit, which has the battery cells and the BMS interface, fusing, pre-charge resistors, all those small details that makes the system tick and be operational. Those usually have not been the cell manufacturers, but that is now becoming more vertically integrated because of these very tight margins in every step way down. From that, of course, comes the cell next. So manufacturing the cell, coating the foils, taking the powders and solvents and liquids and putting them to the cell and knowing the mixtures and the machine tune up that how the cell is made, what kind of properties you expect for the cell. So that there's also specific knowledge that how do you make a good enough cell, not too good, which is too expensive, or not too bad, which is also too expensive because you need to keep replacing them. So then, of course, comes down to the raw material manufacturing, where someone takes in the precursor materials and builds the cathodes and other components for the cell before they are assembled in a cell factory. And there's also this kind of IPRs. You have a process facility that processes the materials to the next stage. And that basically goes down to all the mining. So someone has to take the semi-made material and refine it a bit further. And usually those steps are protected with some kind of patent pool or patent portfolio. So that's why you have these tight kind of holds on certain materials, like we had with the thermally closing separator film, and how that patent voided a few years ago, and prices plummeted like 80%. Partially was the reason why this revolution started with the battery industry. So some key patents went old, and the prices kept dropping. And we are seeing now every year a new set of patents that are going out. That means that there's more producers, but more competition. So when you go down to the actual digging it out of the ground, or digging a, let's say in our case, taking the wood pulp and using the organic sources, you have different kind of ways to procure the materials and refine it. But it's always huge amount of volume of something, and then you start concentrating, and then you mix it together and make it the active unit, and then you build a system around it, and then you build a financial system around it, and then it makes business and makes the world revolve. So that's basically the value chain, that you have these steps.
Wow, thank you very much. This is very good. So you are basically saying that a lot of competition and a very high value add is the sort of like an end product now, financing, and how do you package it in and for a particular use. And along the value chain of manufacturing, as the more patents are coming out, it's becoming more competitive, and that's why it had been prices. Now we hear about a lot of people say, oh, with so many electric cars, the world will run out of lithium battery. Then someone said, we have enough lithium in Bolivia or somewhere. And I know that Australia has the major lithium in the last few years. Where are the lithium globally?
Well, lithium is so light metal that during the billions and millions of years, when the world has revolved in this universe, the light metals have circulated on the top when we had a bit more hotter ground beneath on the earth. So actually, lithium is almost everywhere. It's in the seawater. You can distill it from there if you want. Of course, it takes a lot of energy. But then you have these old seabeds that have concentrated the salts, like in South America. But also there's certain rock types like spodumene that we have in here in Finland, also in the bedrock, and we big stripes of it. So there's it's like I don't know if there's some cake or coffee that you've stirred with a dark and light material. You don't stir it completely, but you can see the stripe in it. So in the same way, when the world has revolved, we have all over the world, basically, you can find these kind of formations of different kind of light metals like lithium. So we are not going to run out of lithium. And the problem with the lithium ion battery industry is, of course, that lithium has been used as in a lubricant and all kind of process additives. So even in medicine. And so those uses have been quite small, and the price has not been very big. So it hasn't encouraged investors to go put everything on a lithium mining project, but that has a bit changed. So there's a lot of capital now revolving around different kind of projects, and we expect that these mines will be starting producing lithium hydroxide or lithium carbonate in quantities that we can use in the battery industry. The biggest problems are with other components which have been traditionally used. In the 1990s, we used lithium cobalt oxide, and in the early 2000s, lithium manganese oxide, and these were quite pure cobalt and manganese. But then we started mixing NMC, so adding nickel and manganese and cobalt and making different kind of mixtures to reduce the amount of cobalt and making the battery a bit more stable, because LCO and LMO cells were not that stable. Well, LMO was much more stable than LCO, but still, we had to really design things around the cell to make it more hard to make thermally run away. So different kind of additives and designs for the cell structures and these heat sealing separators were used. But it was very difficult basically to find ways to make safe cells. So we've taken iterative steps from LCO to the NMC, and already 20 years ago, Chinese projects used high nickel content cells. So there was already very, very high nickel content NMC, and they became unstable again after a certain amount of nickel, which was a bit too much. So there was certain level that found, but at the same time, the lithium iron phosphate came in. So Chinese put a lot of effort to figure out how to make iron phosphate cheap and very operational. And that's how the electric buses became in China the success story. And it gave kind of the path to rethink the battery raw material base and the value chain completely in a way that we can find pure enough raw material sources to actually go around these cobalt and nickel and manganese issues in NMC. And that's why you see now Volkswagen and Tesla and basically everyone else, all the automotive manufacturers are going for LFP. Battery energy storage is grid connected. They have also gone to LFP already, and there's a huge volume of orders on the table. So the problems that we see about the cobalt and child labor and all these kind of negative nuances and news, which are horrible stories, can kind of gone around. We don't have to go and walk on that mine that we see well ahead. We will be able to produce with the current sources iron phosphate, lithium iron phosphate batteries. I think that with today's knowledge, maybe 40 terawatt hours annually is doable. Why that comes into a question, how and why certain components are then kind of the issue. But for example, just to put it in perspective, we are going to use in new factory designs a cell-based paper separator because of iron phosphate stable design. And if you look into the cellulose volumes globally, it's about 80 million tons annually. So if we produce 10 terawatt hours annually phosphate batteries, we would add barely about 3 million tons of cellulose consumption on the 80 million tons. So it doesn't even make a dent. And that replaces a lot of binder material and a lot of different kind of other additives that are not yet in the scales that could met in the big production. So in short, I'm not worried at all. I think it's just that people are staring a bit too much backwards and looking what kind of cells we made in the past 20 years and are not extrapolating the future that is coming ahead. And it's much more diversified from the raw material sources than many dare to say.
So two things take away that you don't have, the LFPs don't have nickel and other heavy metals. So of course, the disposal becomes very easy factor, right? Because lithium is naturally occurring, iron is, phosphate is. So the end product is really not toxic to human.
Correct. And yes, and well, of course, when you have a battery fire, there's usually all kind of stuff that the gases might be poisonous, and usually that's with any household appliance. There's insulators and stuff like that create gases that are not very healthy to be inhaled. But yes, I believe that because in simply said, the phosphate is a manure. It's been used as thrown in the fields to make plants grow. So my dream is that the cells that we would be producing in globally in big scale, when they come to the end of the life, of course, they are easily recyclable, but you can just take a knife and cut the hole on the cell and plant the tomato seed in there, and it will grow.
Because NPK in any fertilizer is sodium, phosphorus, and potassium, right? That's NPK.
Yeah. So it's not dangerous that much, but not healthy to eat directly. So you better grow plants out of it first.
Other thing I always get intrigued, Australia has a lot of iron. Australia feeds Japan and China with a lot of raw iron. Now, right now, Australia is producing, I think, more than 80% of global lithium. So every time I post on LinkedIn saying we should have a huge lithium manufacturing in Australia rather than exporting this raw material, people say, oh, no, this is more complex than that. What's your view on that?
Well, the demand is going to be huge for the end products too. And it's not reasonable to assume that all the cell production and system production is centralized. So eventually there will be maybe one, maybe two terafactories in Australia, and there will be battery manufacturing. So why not make a national strategy to support more higher refined products and take a cut in the bigger margin play and build it right from the start. We have the same problem here in Finland, that we have a very relaxed mining regulation. So basically, if you find a chunk of gold on the ground, you go to the local office and basically apply with 2,000 euros or dollars a permit, and then you can take all that stuff out and sell it in the market and pay just maybe some taxes to Finland. So it's a kind of legalized robbery in the national resources way. So I urge every country to look into their own raw material base and think ways to distribute the global investments in the battery manufacturing value chain and make more value for your citizens, because this technology is something that will really make a big dent on the climate crisis by adding the flexibility needed, and renewable energy can really flow freely then in every place, and that will knock the oil, gas, and coal completely out of the energy mix, and we can't do that too fast, basically.
And then coming back and also to the Australian context, because Australia has exported traditionally iron ore in raw and imported back steel in cars, right? So I think now maybe an opportunity to add the whole electric vehicle value chain starting from lithium, because large part of electric vehicle is batteries. Right?
Yeah, and I've understood that there's some coal reserves also in Australia.
Yeah, of course. Coal is there, but coal sort of will remain underground where they belong, because
True,
where the global market is.
But it's depending on the coal quality, you can use that as an electrode additive. So you can actually refine a carbon-based component out of the coal to anodes, and that is one big volume that is needed.
Okay, so the coal can be part of the battery sort of infrastructure. Okay, that I did not think about that before. Okay.
Yeah, it's there's a lot of petrochemical products, even polymer electrolytes require some component sources from the oil, but it's much more smarter to tie it into the battery for 30 years than burning it into the...
And then it can be very easily recycled as well, right?
Yes, and this is something that we need to take in account when we design new battery cells, that how recyclable they are. So my approach have been that with inert gas and high temperature enough, you will get very nice gravimetrically kind of separated powders that can be used almost as is into the next cell patch.
Yeah, and
But
coal
that's
you don't
still,
have to
of course,
recycle, right? Coal is a naturally occurring substance. Coal is has no harmful. It's the problem when you burn it, right? Otherwise,
yeah,
coal
it's
is harmless.
right. And this is like first the power wall is on the wall, but then it's in the bench and you grow vegetables out of it. So what kind of future lies ahead after 30 years? It's really hard to say, but what we've seen in the past 20 years, only thing that has not changed is the hype for the hydrogen. So it's still been coming on the next year. Last 25
hype
years.
for hydrogen. I mean, I looked at the numbers the other day that to make hydrogen viable, you need solar prices to fall to 0.5 cents a kilowatt hour. And by that time, battery will be maybe $20 a kilowatt hour. Now, if battery is $20 a kilowatt hour and solar is 0.5 cents a kilowatt hour, why you need hydrogen again? I mean, the numbers doesn't add up. Simply doesn't
That's
add
true.
up.
It's exactly. And only thesis for having this kind of longer term, longer duration energy storage is because some people are talking about seasonal storage.
Yeah, seasonal, I understand.
Already in that regard, the seasonal storage, we have a lot of different kind of ways to go around it. And in here in Nordics, we talk about the cold and dark winters when the sun doesn't even come up during the winter time. So we have like one hour day in the midwinter or something like that. But in the summertime, we have no night. So it's 24/7 solar. And that means that during the daytime, there's a lot of excess energy that is just dissipated as in a heat. And in many regions, you can make ground heat kind of wells.
Geothermal, so right?
No, not geothermal, but a energy storage that you just drill a 10-meter or 15-meter deep hole on the ground. And during summertime, you transfer the heat from the surface of your building below the ground and below the building. And during the winter time, you circulate water through those with the heat pump. So you actually use the ground as an additional heat storage for seasonal variation. And that has been well established and tested, and it's quite easy and simple and cheap. But there has been some kind of misunderstandings how it works. So I'm not worried about the seasonal storage. The sun shines continuously still millions of years, hopefully more longer. And that radiation is raining on the Earth every second. It's just a matter of building the right kind of infrastructures with high efficiency, and it's kind of, we have this kind of a bit old thinking that the energy is created and provided according to demand, while we have now much more control on the demand. So it's more like arrange the demand when there's generation. So it's going another way around.
Yeah. I mean, especially soon, in my view, that all appliances will have built-in batteries. So your demand will not be no longer instantaneous demand, right? Demand will be like a trickle demand, right? Like your computer, when you switch it on, it doesn't ask for its watt to the grid. It takes its battery first, and the battery takes trickle amount from the system, right?
Yeah, and these all kind of neat little innovations in the energy efficiency, like the LED screens, for example. If we look how much did a 85-inch TV consume 20 years ago compared to today.
Yeah, must have been 500 watt. Now maybe 50 watt.
Yeah, not even that probably. And it's when you consider that you have 85-inch TV and maybe it's a 2.5 centimeters thick TV, you can integrate there several kilowatt hours of battery. without any huge extra cost. And because of that battery, that the power electronics that is needed to maintain the charge level becomes much cheaper, and there might be some design things, but what if we have a TV that works for 1 week or 2 weeks with one charge? What does it mean? Does the TV participate to demand response scheme and actually earn itself back? Who launches the first TV that pays itself back? These kind of really open thinking themes should emerge, and I'm looking forward on stoves, microwave ovens, washing machines. All of these systems can have integrated battery in certain way, and I know that people are looking into this. In vacuum cleaners, that's already standard.
Vacuum cleaners. I have seen television. I have seen, of course, you see light bulbs, fans. All of these have batteries now. And so
it's going to be everywhere.
So what's
I believe
your?
Also that,
go ahead.
So this integration in homes with something what Tesla has also shown very strongly, that roof integrated solar and energy storage at the building. It's really turning around the table completely in the energy sector. So the consumers and prosumers become the investors in the energy sector, and that's and the financier are the banks who are providing the mortgage. So this is really affecting hugely on the energy market, and that is the reason why I've been looking into this very strongly, that how we can mitigate the problem in the banking industry at the moment, because there's a lot of stranded assets, and those are just losing value. And we are not talking about millions or billions, we are talking trillions. That's going to make a dent if it just vanishes. We need to have something to hedge with, and to provide that hedging tool to the investors who are now looking into the eyes of the Grim Reaper. It's not going to look very nice when the assets go zero value because volume goes out. No one buys the energy. So this household appliance and distributed energy system needs a different kind of financing tools and different kind of thinking. So that was kind of the point, that batteries are going to be everywhere, and then there's abundant amount of flexibility. What's next?
So taking that discussion forward, so what will you recommend to a new entrepreneur who just want to get into this industry, who is very keen but maybe not know where to start, wants to do something related to battery? As a battery expert, what you suggest? Where do they look first?
Well, this is of course multi-level question. If someone is looking what to study, for example, what the options are in the schools, basic material science is a good approach, but also because this business is going to grow big, really big, there's going to be a lot of different kind of skill sets that we need, from the financing, from the system design, but also to rethink the social aspects. Because if you have the distributed energy storage systems in the people's houses, you effectively have knowledge about their energy consumption and stuff like that. So there's a lot of social and legal things that need to be kind of taken in account. So in specific, there's a lot of different things that are available in many schools. But if you take that kind of approach, that keep always kind of mirroring what you are learning, that how does this probably affect from the battery standpoint of view, if you want to be in that field. So study what you want and you have a passion for, and go for it. There's going to be a lot of demand for people to do these things. Then again, from the entrepreneurs, the first rule in every entrepreneur who wants to do anything is to identify the demand. So if you don't have demand, you are just wasting time, basically. If you are trying to build the demand, then that requires so much capital that you need to have either something extraordinary patience in your soul. You need to be really zen or something to go and fight the market to get that demand. But mostly demand is there. People are not easily telling about that, but when you identify that yes, there's a local need for electric bike charging station in the bus station or train station or whatever, go and do the business plan. Ask help from local incubators. There must be almost in every region there's some business entrepreneur support network that provides help to make the business plan and think that how the revenue streams are coming in and what are your costs and so forth. So basic business mathematics. So yeah, identify the demand and then be passionate about it.
Yeah. That's a very good advice, that identify the demand and be passionate about it. Now, what's your sort of advice in terms of looking for resources? You mentioned there are a lot of resources available to understand battery tech startups. Where can they look? Are there any specific resources that people can look to understand what's happening in the battery?
Well, I think the internet is full of stories. So when you look into the scientific community, you look into the white papers that have been peer reviewed and listen the people who are active in the industry and listen carefully what they are saying. Even some wildest ideas that might seem really strange and odd and even crazy have a merit, because everyone has their own context. So everyone who are working in the battery industry, we have different kind of approaches. Some are chemists, some are business developers, some are application developers and so forth. So we have a different insight, and listening those even the open webinars and presentations in YouTube and so forth, it brings the basic knowledge level already to the part that you can start sourcing the material from the internet. So I think internet is the best thing that have happened in this regard. You have access, and we can have this discussion over the integrated networks globally. This is information is important, but it should be more freely. So read patents also. That's one thing. So go patent pools and search for certain keywords and try to understand what they are saying in the patent applications. So you get a bit better picture that what kind of things people had in their mind 4 or 5 years ago, and that gives you some idea. Also that in technology wise, but from the business wise, it is again, recognize the demand. What is the demand? That helps to go and aim your information research on that certain topic, and there's a lot of problems to be solved. So whatever problem you see, start solving it. And there's a lot of problems that we need to solve.
Yeah, back to basics, right? Now, you mentioned earlier about incubators. Is there any specific battery incubators that you will recommend people to look up? Anyone?
Well, I don't know exactly if there are such. I think in almost every country, every university have some kind of battery laboratory nowadays. But the basic research is done there usually. So it's raw material development, cell compositions, different kind of coin cell tests, and so forth. So you have a lot of practical testing in the base research there. But in the business schools, I really can't say. I think these largest, bigger, kind of globally well-known universities, they provide quite wide range of different kind of courses, even online courses. But incubators, this is if you're talking about business, business has one rule: make money or die. It's very simple and universal code. So all of incubators can do that, and then you just specify what kind of business kind of ideology you want to develop.
So you're saying, to summarize, that people should they want to study material science, really look through the patents, what had been the thinking of people, and then identify demand and solving a specific problem. Then, of course, there's a plenty of those, right?
Yeah.
That's a very good advice. So what's your view as a battery expert on the future of lithium-ion battery prices, dollar per kilowatt hour? Do you have any farm-held views?
Well, I've already stated publicly that my view is that we are definitely below $20 per kilowatt hour on the battery system price by 2030. And we, and that's not only the cost, but the cyclability and the lifetime of the cell, because of the solid electrolyte structures, they do not deteriorate in the same way that liquid electrolytes. So we can expect 30, 40, 50-year lifetime out of solid state cells, which are not using metal anodes. So the standard graphene, advanced carbon, lattice-based, and even additive silicon, and so forth. These anode compositions provide huge stability, and with the iron phosphate as a cathode, that is, we are going to see 50-year batteries again, just like the Edison iron battery. They can survive hundreds of years. So these, it's not kind of new approach. It's just not so volatile setup anymore, because we are looking for energy storage sectors too, which are looking for long lifetime, not just lightweight. So if you compare to the battery development that we had to the 1990s, it was handheld devices, then electric cars. Those both were very demanding on the lightweight structure of the cell and high energy content. But now the energy storage business is the main driver, and it doesn't have this issue. So now it's just cost, and that will drive the cost even further down. And because of the iron phosphate and these outgoing patents, the prices of the components will come down. So this below $20 per kilowatt hour by 2030 is based on about $8 per kilowatt hour of raw material cost on the iron phosphate cell in 2030. But let's say that this is a kind of wild statement, but what if the oil and gas and coal industry decides that they need to find a place for their CCS products? We can store their carbon dioxide as a battery raw material. Can we have a situation where the push to level kind of mitigate the stranded asset risk, we end up having raw material costs that actually are close to zero on certain components, because they need to store it somewhere. So we provide a small compensation to receive the captured carbon and use it as a battery raw material. So if we can achieve these kind of loopbacks from the existing dyeing industry, we will see extraordinary low prices, ridiculously low prices, unimaginable prices. It's like negative energy prices in certain markets when there's overproduction. So these loops, when you build them, you have a behemoth that will really eat the market.
Yeah, I mean, this is scary in a sense. Let me understand the numbers. A typical car, say Nissan Leaf, takes about 20 kilowatt hour to do 100 kilometer. Some cars take only 15. You are saying a 20 kilowatt hour battery at $20 a kilowatt hour will be $400. And you will be able to print an electric car on your 3D printer, maybe in future, not so distant future. So the car prices will be super cheap, because if your battery is only $20 a kilowatt hour, no?
Yeah,
because it was more than $1,500 a kilowatt hour less than 10 years ago, no?
Yeah, but this whole, if you look into the whole social economics of every society and think about that, the households, the homes become energy generators and energy flexibility providers. That means that more bigger house you build, more money you earn. So if you think about this, how it distorts the whole office space market, for example, what happens to these high skyscrapers when people actually want to have larger houses in the countryside that are in, and you can drive your car from the 300-kilometer trip almost with no cost to get your groceries or whatever. So these kind of, and not even talking about drone deliveries, thinking about how much the cost of drone deliveries come down in certain things. So will we be working due the corona and the COVID has taught us that remote working is actually quite efficient? Will we never assume into the same thinking that we had 2 years ago? I'm saying that we are witnessing now the start of lithium era in a way that it was boosted by global pandemic, and the revolution gets now on the steroids basically, and I'm hoping that that's the case, because that gives us even some slight hope to tackle the climate crisis that we are in. So you've got numbers right. The revolution is here, and this is how it looks like.
Yeah, amazing. I mean, this discussion can go on and on. I don't want to take too much of your time. Thank you very much. Is there something else I could have asked you, or you want to highlight, or you have a question for me? Anything?
Well, I've been always eyeing to the Asian market and been quite a lot of spending time in China, but not in other regions. And I know that there's a lot of solar deployments and interest to cut the emissions locally. So I've really hoped to see these e-jeepney projects take off very well, and getting the e-mobility in the smaller units in the crowded streets. So I really hope that this revolution that and the lithium era will boost this transition to get rid of the local pollution, because some prototype cities like Shenzhen in China, now all the buses are electric, and all the two-wheeled and three-wheeled city scooters are electric. And now the taxis are electric. Everything is going electric. So you can really feel the fresh air in the city when you walk in the city. It's a huge change during the past 15 years that I've been there. And I hope that same thing to happen to every city in the region in there. So everyone do everything to get that done. It saves lives and makes life much more worth living.
So yeah, I'm sure some of my listeners are working on a project like that, and they will love to understand what they can learn and what is the right direction to go forward. How can people connect you? I'll get your email and all details added here, but is there you have a YouTube or any other social media things that people can follow you on?
Well, I'm currently every Thursday, I'm running a Clubhouse meeting called the Battery Chat. And it's 7 p.m. Eastern European time scheduled, and on one can find it with the search or with the Battery Chat. So I'll put a few days before the event always the invitation in the calendars in the Clubhouse, and anyone can come in and ask questions. So just raise hand and you can ask a question, and I'll try to answer. And if I don't have the answer, I will ask my friends, and probably someone has the answer for the question. So there shouldn't be any battery question that cannot be answered with the network that I have. So a lot of good scientists and researchers are available there. That's a good way.
Fantastic.
So I'm trying to contribute a bit, sharing the knowledge, and this is also a reason to do these podcasts, that the people get a bit more, probably not so hype, but more neutral and more kind of, I'd say, through the execution of the past 20 years, some background that what has been done and why. So it gives a bit better insight. It's not only the hype on the media that the next Marvel battery is coming. It's actually quite pragmatic daily work to get these improvements to clients and customers to be kind of.
Thank you very much. I'll look you up and I'll join also the Clubhouse chat. Clubhouse, you said the battery chat. Thank you again.
Yes.
So let's keep connected and have a great evening. Thank you, Jukka.
You too. Thank you very much. Let's keep in touch.
Okay. See you. Bye.
Bye.
Thank you for joining us this week. If you haven't done so yet, subscribe to our show. Also, leave your comments and review if you enjoyed today's episode. Follow me on LinkedIn and Twitter at @shasni for updates. That's SHASNIE. Once again, this has been Energypreneurs, connecting you to the innovative opportunities in solar power, batteries, and electric vehicles. Stay tuned.